This chapter is on solving systems of equations. As you can see from the title here, after this first lesson, we're going to be tackling the topic of matrices, and in particular, how we use those to solve systems of equations. With that said, however, the first section here is on the old-fashioned hand technique. There is a separate video that has a very detailed guide for these techniques. But here in the beginning, we're going to take a look at the technique called substitution. And here's how that goes. We want to pick one of these two equations and solve for either of the two variables. I'm thinking that this second equation here is going to be real easy to solve for x. If I add 2y to both sides, the 2y will disappear, and we'll have x equals 1 plus 2y, or 2y plus 1. You can write it either way. Then the next step is to take the other equation. And I'm going to write this equation down below this one. 4x minus 3y equals 14. Now, in place of that x in this equation, we're going to use something that x is equal to. So now we come up with an equation that has only a single variable. We can solve that from techniques that we've learned in the past. So we'll multiply here. We will put things together that are compatible. We will move the 4 to the other side. And finally, when we divide by 5, we have the value of y. Now, in solving systems of equations, you need to come up with values for both variables. So next, what we do is take any equation involving this problem and use the answer we just got to figure out what x is. Now, if we take the equation that we wrote here, x equals 1 plus 2y, we can substitute the 2 that we just solved for y. And we find x to be 1 plus 4. Now, the last order of business is the proper way of writing the answer. The answer is written as an ordered pair, meaning with parentheses, and the x's first and the y second. The other hand technique that is quite common is known as elimination or addition. Now, the way this technique works is we want to look at the columns involving each of the variables. We need to adjust coefficients so that they match and are opposite in sign. Now, I'll show you what all that mess means. We're going to take this top equation and we're going to multiply the top by 2 and the bottom by 3. See, we're just kind of switching these two numbers. So I'm going to write that right here. I'm going to multiply this by 2 and I'm going to multiply this by 3. So in the top, we'll have 2 times 2x. We'll have 2 times 3y. And we'll have 2 times negative 1. In the bottom, we'll have 3 times 3x. We'll have 3 times negative 2y. And we'll have 3 times 18. So now we add in columns, and we get 4x plus 9x, which is 13x, 6y, negative 6y, which is 0. So we won't bother writing that down. And then negative 2 plus 54. And like with the previous technique, we now have an equation involving a single variable. To finish solving that, we'll divide both sides by 13. And just like with the previous problem, once we get this, we need to substitute in any of these equations a 4 for x and figure out what y is. I'll just take the very first one. That's 2 times 4 plus 3y equals negative 1. That's 8 plus 3y. Subtract 8 and divide by 3. And the proper answer looks like this. Notice on this one the instructions don't specify a particular technique, so we kind of have our choice as to what technique we want to use. In looking over the problem in the beginning, we see that none of the variables are without numbers, so I probably wouldn't choose the substitution method. So to do the elimination method, we're going to need to decide which variable do we want to eliminate and multiply appropriately. So I'm looking at the y's, and I'm thinking, well, if I just multiply by 2, these will subtract out. So I'm going to write times 2 on this one. 7 times 2 is 14x. 3 times 2 is 6y. 2 times negative 5 is negative 10. I'm going to write the bottom one right underneath it without doing anything to it. Then I'm going to add 14x and negative 14x is 0. 6y and negative 6y likewise is 0. Now negative 10 and negative 10 is negative 20. However, 0 equals negative 20 is a false statement. It's not an answer. 0 is not the answer. Negative 20 is not the answer. The answer is that there's no answer. There's no solution. There's no value of x and y that would make both of these true. And again, that's because what we ended up with is a false statement. So that we can compare this one with the previous one that we did, I'm going to use the same technique, that being the elimination. This time, again, I'm going to look here at the y's, and I think I need a 3 here, so I'm going to multiply this one by 3. They will have opposite signs, and everything will be okay. So 3 times 3x is 9x. 3 times negative y is negative 3y, and 3 times 8 is 24. We're doing nothing to the top one, so we'll just write it down. And then add. Negative 9x and positive 9x is 0. 3y, negative 3y likewise is 0. Only this time we got negative 24 and positive 24, which is also 0. No x's or y's in the bottom line. There is, however, this statement, which is always true. Which means, as you can see in the instructions, there are infinitely many solutions. We'll just put infinite. I'll show you how to use the elimination method on this, mostly so you'll appreciate what's coming next. However, here is what I'm looking at. I'm going to take these bottom two equations because the y's match and have opposite coefficients, and I'm going to add those together. So there's a 2x plus y plus 2z equals negative 9, and x minus y plus z equals negative 9. So when I add those, there's a 3x, 0y, 3z, and negative 18. Now, we'll go ahead and simplify that by dividing through by 3, which would make an x plus z equals negative 6. Same equation. Now, the kicker is we haven't actually solved anything. We still have an equation, which we can't solve because it's two variables. So what we need to do in our original system is to pick out two other equations. Now, we can either use the top one and the middle one, or the top one and the bottom one. But what we have to do, just like we did on this one, is to eliminate the y's. So I'm looking at this top one, which we've got to use, and since there's a positive 4y, I'm going to choose the one that has a negative. So I'm going to use the top equation. I'll write that down. And the bottom one. And do the same thing that we just did. In order for the y's to subtract out, we've got to multiply this bottom equation by 4. Leaving the top one alone, and multiplying the bottom one by 4, and adding. Okay, so what we've accomplished really is we've got the problem narrowed down to this. We need to solve x plus z equals negative 6 and 7x plus 2z equals negative 22. So whatever we decide to do, we could actually do the substitution here by solving the first one for x or z and substituting into the second one. But we'll stick with the elimination method. And I'm looking at this and thinking, if I want to eliminate the z's, I need to multiply this one by negative 2. And copy the other one down. Add them together. That would be a 5x, 0, and negative 10. And we can finish solving that rather easily. Now, just like before, once we get this answer, we need to substitute to get one of the other letters. Well, the key is don't go all the way back to the original because you still have two other letters. Pick out some of the equations that only have 2 letters. I kind of like the top one, x plus z equals negative 6. So here's the x that we just found plus z equals negative 6. So I'm just taking this equation, and that'll tell me what the z is. If I add 2, so now that we have 2 of the answers, we need to take one of the equations. I'm kind of partial to this bottom one here because it has less numbers. So x, that's a negative 2, minus y, that's what we're looking for, plus z equals negative 9. So we can put the negative 2 and the negative 4 together, and that would be a negative 6. We can add 6 to both sides, and then multiply through by negative 1. And just like before, here's the proper way of writing the answer. The x comes first, then the y, then the z.